A mole is a collection of 6.022 into 10 power 23 elementary entities. It can be atoms, molecules or ions. Percentage composition is the percentage by mass of each element present in a given compound. What is empirical formula? It is the simplest whole number ratio of atoms in a compound. Good morning dear students, I am Roja, your chemistry lecturer from Vidhyaashram PU College, the Temple of Excellence. Today we shall continue the chapter Some Basic Concepts of Chemistry. In the previous session we have learnt about laws of chemical combinations and Dalton's atomic theory, and in today's session we are going to learn about mole concept, percentage composition, stoichiometry and stoichiometric calculations. So let's get started. Atoms and molecules are so tiny in nature that it is impossible to count them one by one. So the scientist invented the counting unit called a mole. What is mole? A mole is a collection of 6.022 into 10 power 23 elementary entities. It can be atoms, molecules or ions. Just like how we have 1 pair is equal to 2 units or 1 dozen is equal to 12 units. Similarly, we have 1 mole that is used to count the number of particles or number of elementary entities in a given substance. So, it can be atoms, molecules or ions or any other specified groups. This number, which is 6.022 into 10 power 23, is called as Avogadro number or Avogadro constant. It is denoted by Na, meaning Avogadro number. Say for example, 1 mole of hydrogen atom consists of Avogadro number of particles, that is 6.022 into 10 power 23, or 1 mole of hydrogen molecule, that is H2, consists of 6.022 into 10 power 23. Irrespective of any of the elementary entities, it contains Avogadro number of particles. Now, having defined the mole, we can calculate the mass of the given substance. It can be an atomic mass or a molecular mass. And atomic mass and molecular mass are expressed in U, that is unified mass. If the atomic mass or the molecular mass is expressed in grams, then it is said to be known as molar mass. The 1 mole of a substance weighs the same as its atomic mass or molecular mass but in grams. So, it is called as molar mass. Suppose 1 mole of hydrogen weighs 1.008 grams. That means it contains 6.022 into 10 power 23 number of particles. And 1 mole of oxygen molecule, suppose it weighs 32 grams, then it contains Avogadro number of particles. Now let us analyze this table. Quantity, that is in terms of number of particles, if you have to calculate for 1 mole of any of the substance, it would contain Avogadro number of particles. In terms of mass, which is expressed in grams and also been called as molar mass, contains equal number of particles, that is Avogadro number of particles. What if the given substance is gas? So, 1 mole of a gas or of an ideal gas at STP, that is at standard temperature and pressure, then it contains 22.4 liter volume of a substance. So, that is how this is been used for to find the volume of a gas. Say for example, 1 mole of oxygen gas means it would contain Avogadro number of particles. This is in terms of particles. Also, What if it is expressed in mass, that is molar mass? Atomic mass of oxygen is 16 U. If it is expressed in grams, it is 16 grams. Since it is in a molecular formula, it would contain 32 grams. Therefore, 1 mole of oxygen gas would contain 32 grams of a substance. And also, since it is an ideal gas, what will be the volume? Volume will be 22.4 liter provided at standard temperature and pressure. So, 1 mole of a substance can be defined in these terms, in terms of particles, in terms of molar mass, in terms of volume. So, therefore, a mole is a chemist's way of counting the number of particles using a big number, that is Avogadro number, just like how we use dozen or a pair, something like that. Now, we shall learn about percentage composition. Percentage composition is the percentage by mass of each element present in a given compound, and it is expressed using the formula percentage of the particular element is equal to mass of that element in 1 mole of a compound divided by molar mass of the compound multiplied by 100. Now, we shall understand by giving an example of water, which is having a molecular formula H2O. So, the molar mass of H2O is 2 atoms of hydrogen and 1 atom of oxygen is present. So, it is 2 into 1, 1 represents the atomic mass of hydrogen, and 16, since 1 atom of oxygen is there, so it is 16, 2 plus 16 gives 18 grams, that is for per mole. 1 mole of water molecule consists of 18 grams. Now, mass of hydrogen, we know it is 1 gram. Since it is 2 atoms of hydrogen present in water, it is to be multiplied with 2, it gives 2 grams. And mass of oxygen is 16 grams. Now, we shall see how to calculate. Percentage of hydrogen should be calculated, that is for the individual element which contributes for that particular compound. Now, it is given by the formula, you know, mass of that element present in 1 mole of a compound divided by molar mass of the compound. So, therefore, mass of hydrogen is 2 divided by 18 grams, that is molar mass of water, that is multiplied by 100 gives 11.11%. Then the other element present in the compound is oxygen. Oxygen mass is 16 divided by the molar mass of water 18 multiplied by 100 gives 88.89%. Therefore, the percentage shows that so much percentage of hydrogen and oxygen are present in this 18 gram of a molecule, that is 1 mole of a water molecule. So, next topic we shall learn is about empirical formula for molecular formula. What is empirical formula? It is the simplest whole number ratio of atoms in a compound. For example, glucose, the molecular formula of glucose is C6H12O6. Now, how to arrive at empirical formula using this molecular formula? So, first we should know the ratio between carbon, hydrogen and oxygen. So, that is C is to H is to O. So, the ratio is 6 is to 12 is to 6. Now, this is to be divided by the simplest whole number ratio, that is to be divided by the 6 number. That is the case. So, you will get 1 is to 2 is to 1. That means carbon is having 1, hydrogen 2 and oxygen 1. Then after simplification of molecular formula, you can get the simplest whole number ratio between carbon, hydrogen and oxygen. So, that defines the empirical formula of glucose. So, CH2O is the empirical formula for the glucose molecule. Therefore, we have one more formula, that is molecular formula is equal to N into empirical formula. If you have to find molecular formula using empirical formula, that you have to multiply that number which gives the actual molecular formula of the compound. Okay, now we shall try to solve this question. A compound contains 4.07% of hydrogen, then 24.27% of carbon, and 71.65% of chlorine. Its molar mass is given 98.96 grams. Now, what are its empirical formula and molecular formula? So, first that you have to write what is given in the question, that is percentage of hydrogen is 4.07%, percentage of carbon is 24.27%, and percentage of chlorine is equal to 71.65% present in a compound. Now, how to solve this? It's given in a percentage formula. Let's assume that there is 100 grams of compound. So, the amount of hydrogen present in that 100 gram of compound will be 4.07 gram. Then carbon will be 24.27 grams. Then chlorine will be 71.65 grams. So, it is just that replacing percentage by grams, assuming compound would consist of 100 grams. Now, let us solve using this given data. First step that you have to follow is convert the given grams into moles. Moles of hydrogen is equal to mass of that hydrogen that is present in that particular compound divided by mass of hydrogen atom. So, when we divide, you get 4.04. Similarly, for moles of carbon is present around 24.27 grams in that compound divided by the atomic mass of carbon is 12.01. So, when it is divided, you get 2.02. There is one more element, chlorine. So, moles of chlorine is equal to 71.65 grams of chlorine is present in that compound divided by the atomic mass of chlorine is 35.45. So, when it is divided, you get 2.02 moles. The second step is divide all by the smallest number of moles that you have got in the answer. So, here we got 2.02 as the smallest number. So, we will try to divide. If moles of hydrogen, that is 4.04 is divided by 2.02, you get 2.00. Then moles of carbon is equal to 2.02 divided by 2.02 gives 1.00, and similarly for chlorine 1.00. Now, using these number, how to write the empirical formula? First, arrange it. So, there is the ratio between carbon, hydrogen and chlorine is the thing that we have to find the compound. Now, the number of moles of carbon that we got is 1 is 2. Number of moles of hydrogen that we got is 2 and chlorine is again 1. Therefore, it shows carbon is of 1, hydrogen is of 2 and chlorine is of 1. This is the simplest whole number ratio that is arrived with. Now, if we put together, we get a formula, empirical formula of a compound, that is CH2Cl. That is the ratio that we got. Okay. Now, what is the next thing that we have to find is, find the empirical formula mass. It is necessary to find the empirical formula mass. Now, what is that empirical formula mass? It is the mass of the obtained empirical formula. So, obtained empirical formula is CH2Cl. Now, for that we have to calculate the empirical formula mass. So, carbon mass is 12.01. Hydrogen is present twice. So, it is 2 into 1.008. This is the mass of hydrogen, and chlorine is 35.45. Now, according to the formula, if we put together into the formula, that is 12.011 plus 2.016 plus 35.45, it gives 49.48 gram per mole. Then fifth step is to find the molecular formula using the empirical formula. So, the formula to calculate is N is equal to molar mass by empirical formula mass. So, the molar mass of a compound is 98.96 gram per mole, which was given in the question, and divided by 49.48 gram per mole for CH2Cl. So, upon dividing, we get number 2. So this is the number that we have to multiply with the empirical formula. How it is done? Molecular formula is equal to empirical formula multiplied by n, that is number. When we multiply it, we get C2H4Cl2. So therefore, the final answer is empirical formula is CH2Cl and the molecular formula of a given compound is C2H4Cl2. So these are the steps that you have to follow to find the empirical formula. Using empirical formula, you can find the molecular formula of a given compound. Now we shall learn about stoichiometry and stoichiometric calculation. So stoichiometry is a part of chemistry that deals with the calculation of the quantities, either mass or volume, of reactants and products in a chemical reaction using a balanced chemical equation. If I split the word stoichiometry, in Greek, stoichion is elements, metron is measure. So therefore, it is to measure the elements. In a given balanced chemical equation, the number beside the molecules of the reactants and the product represents the coefficients, which is here 1 mole of methane and 2 moles of oxygen react to give 1 mole of carbon dioxide and 2 moles of water. So that number represents coefficients, which is called as stoichiometric coefficients. Using this stoichiometric coefficients, it can be expressed in different ways. It gives mole ratio, it gives molecule ratio, it can be expressed in volume ratio at standard temperature and pressure, and also it can be expressed in terms of mass ratio. In terms of mole ratio, it can be expressed as 1 mole of methane reacts with 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of water. Similarly, if it is expressed in terms of molecule, that coefficient 1 molecule of methane reacts with 2 molecules of oxygen to give 1 molecule of carbon dioxide and 2 molecules of water. Similarly, if it is expressed in terms of volume, at standard temperature and pressure, it gives 22.4 liters of methane because it is only 1 mole. So it reacts with 45.4 liters of oxygen because 2 mole of oxygen. It gives 22.4 liter of carbon dioxide and 45.4 liters of water. If it is expressed in terms of mass of methane is 16 grams. Mass of oxygen is 64 grams because it is of 2 moles. And mass of carbon dioxide is 44 because it is of 1 mole. And mass of water here in this reaction is 36 grams because it is of 2 moles. So therefore, it can be said as 16 grams of methane reacts with 64 grams of oxygen to give 44 grams of carbon dioxide and 36 grams of water molecules. Next, we will try to solve this question. How many grams of carbon dioxide are formed when 16 grams of methane is completely combusted? So, 16 grams of methane is going to undergo complete combustion in the presence of oxygen to give carbon dioxide along with the water. But here you have to find how many grams of carbon dioxide are formed. Now, how to find that? We should know the balanced equation, that is CH4 plus 2O2 gives rise to CO2 plus 2H2O. So, that is 1 mole of CH4 produces 1 mole of carbon dioxide. Now, what is 1 mole of CH4 in terms of molar mass? It is 16 grams. Now that we have to find the amount of carbon dioxide in terms of grams, that we don't know. But we can calculate the molecular mass of carbon dioxide. that is 1 atom of carbon is present and 2 atoms of oxygen are present in a carbon dioxide, and we know the atomic mass of carbon is 12 plus atomic mass of oxygen is 16, that is to be multiplied by 2. So we get 44 grams. This is molecular mass expressed in grams. So therefore the molar mass of carbon dioxide is 44 grams. Therefore 1 mole of carbon dioxide consists of 44 grams. And here in the equation you can see that is 1 mole of methane produces 1 mole of carbon dioxide. Therefore, when methane undergoes complete combustion, it forms 1 mole of carbon dioxide, which gives 44 grams of carbon dioxide in the reaction. I hope you have understood this session, and in next session we shall learn about limiting reagent and concentration of solution. Thank you.